We are going to create a simple Sudoku solver that can solve the Sudoku for you and give you the output. So for those who don't know what a Sudoku is, let me give you a quick overview. So this is the Wikipedia page on Sudoku. As you can see, Sudoku is a game where you are given a table like this, where there are some numbers and there are some empty cells, and you have to fill those empty cells, and to win you have to put all the numbers in these empty cells, so that the numbers, they follow a special rule, and that rule is you cannot put any number with except 1 to 9. So you can use 1 2 3 4 5 6 7 8 9. And okay, so a number can be put only once in a row, a number can be put only once in a column, and in one of these big 9 cells like this you can put only a single number. So when you solve this Sudoku, particular this one instance, you will get a result something like this. And if you watch closely, you can find that every number, they are unique to their row, they are unique to their column, and they are unique to their corresponding one of these big 9 cells. So what our program will do is it will come up with these 4 6 8 9 numbers, and it will try to fill in the whole Sudoku maze following the conditions of Sudoku. To tackle this problem of solving a Sudoku, we are going to use a very key concept of computer programming in general, and that is backtracking. What is backtracking? Let me give you an example. So here you can see that I cannot put 5 3 6 9 8 7, but I can put 1 2 and 4 here, for example. Now I put 1 here, and then I start putting other numbers here. Now the problem is that at some point I might run into an error what will say that I cannot put 1 here. So what I will do is I will cancel out that possibility of putting 1 here, and then I will try to it 2, and I will go on like this until I reach the last cell, and I complete the whole Sudoku. Now in case a particular arrangement fails, I will go to the last step until which I thought that this was a right implementation, and try out another different combination. So I go back and track the next route. So this is how we come up with an algorithm called backtracking. It's also sometimes known as brute force and so on, but the key concept is that to a particular problem there must be a lot of solutions, and we can represent those solutions as a tree, and we go through that tree in a depth first search. That means we are interested in going down the tree rather than exploring the side branches of the tree. And when we are going through a particular branch of the tree and encounter a particular error, we go back to the next branch, and then we again start exploring. And that's how we don't have to explore all the branches, and if we are lucky we can get the result in first branch, or in the worst case we just have to go through every branch and explore them all to find an optimum answer. So let's create a simple barebone application. So I will include iostream, and I will include vector, and then what I will do is I will create a simple main function, nothing too fancy, and our main function returns 0, which is not actually necessary, but still it's a habit of mine. And also we're not going to be dealing with std namespace problem, so I think I will just put it here using namespace std, so that it saves me a lot of typing of std colon. Okay, so now the first problem that we have is we need to represent this board in our C++ program. So what I think I will do is I will represent this whole board as a two-dimensional array, where every element of the first dimension of the array will represent the rows, and every row will be another array which will contain the individual cells. So to simply represent the board, I will use a two-dimensional array like board, and which will have 9 rows, and each row will have 9 cells. So totally we will have 81 cells covering the whole Sudoku board like this. Now let me quickly copy this data into this array so that we can start working. So here we have our board, where suppose I have something like board 1, and board 1 will represent this line because these are arrays are it's typically 0 index. And then if I put another index here like 2, it will represent this cell. So the number 1 row, assuming that this is a number 0 row, and the number 2 cell of that number 1 row, assuming this is the number 0 cell of the number 1 row, and so on. So the first thing that I would like to implement is a simple function that will print our board into the console. So I will call this function print Sudoku. So void print Sudoku, and it's going to take the board. So int array of 9. Now you don't need to give the last 9, or even you can use pointers, but it will do what we want. So I'm just going with this convention. So first thing, we print out a separator to separate our board like this. Okay, and then we print out this separator again. Now I am using vim binding, so I can do these kinds of thing using some simple commands like yyp and so on. Now we'll loop through each row. So int row equals to 0, row is less than 9 because there are 9 rows, so the last row will be 8. And for each row we'll go through each cell. So for int cell equals to 0, cell is less than 9, cell plus plus, and we will see out the element, that is array rc, the element belonging to the row and the cell, because the first index it represents the row, and the second index it represents the cell, or even you can think it as the column. Okay, and then I will simply say end line. And just let give a simple space here to space the numbers, as I will simply print a new line or end line in order to separate the rows in different lines. So now let's use this function to print our board. So let's say print Sudoku, and we pass our board, and this is our board. Okay, and if we run this, you can see that they're being printed like this because I put a end line here. So just let me quickly remove it. And so now hopefully we should be able to print the board. I just put end line after every character. They just were in every line instead of being in a single line separated by spaces. So yeah, as we can see, we can now print our board into our console, which is not that much interesting. Now the first things first is that from this diagram we have to determine in a cell whether uh, taking a number, let's say 1, I can put that number inside that cell or not. In this case I can put 1 in this cell because 1 doesn't belong to this row, 1 doesn't belong to this column containing 8, and 1 doesn't belong to this cell which is containing 5, 3, 6, 9 and 8. So I can put 1 here, and I have to design that functionality. So here I am just asking a condition that whether I can put a value. So I will call this function can place, and it will be of type boolean. So let's say bool can place, and it will take the array. So obviously the array of 9, 9, and the row and the column where you want to put. So int row and int column. Okay, and this will and obviously the number we want to put. So int n stands for the number. Firstly we will check is whether a cell is empty or not, and as you can see in this board, whenever a cell is empty it is represented by 0. So what I will do is I will first check if the array row and col is not equals to 0. That means there is some value that is not equals to 0, and if that's true I will return false, because I can't put anything on that cell. like this first cell, it already has 5, so I can't put anything on that cell. Now if that's not the case and the value is 0, so we can go further into this function, and what I can do is I can run a loop for int I equals to 0, I is less than 9, I plus plus, and here I can check for each column, each row, and potentially each cell. So first things first, we will go through each column and row to keep track of whether I can place a thing. I will take a simple boolean called status, and I will set it to true. Whenever I find a contradictory condition, I will set the status to false and return that status, telling that you cannot place any number into the cell. So first things first, we will go through all the rows and columns. So if array row I is equals to n. Okay, so what I will do is I will set the status to false and break from this for loop, because I don't need to check any further. Whenever I find a single false, I can get out of this loop. And what I can do is I can apply the same thing for the columns. So here this will be I and this will be call, so it will check through the column, and if it finds that number existing already, it will set the status false and break. Now for cells, we can potentially run a simple 2D for loop and check through all the cells, but I can do a little hack, that is I can find which grid it belongs. Let's say the index for grid X. So the grid X index will be the X index. So what we will do is we will find out the first cell of the grid, because like for this middle grid, if I want to put a number here at the middle of this Sudoku maze, okay, which is 1 2 3 4 5 comma 5 is the row and column. So what I want, I am interested in finding this cell, because from this cell I am going 3 cells this way and 3 cells this way, and I am covering the small grid. So to do that, what I can do is this is 5 comma 5, so I can divide 5 by 3, which will give me the grid number according to the row and the grid number according to the column, and then I can multiply it with 3. So I will only get 3 0 3 or 6, or in vertical also I will get only 0 3 and 6. So I will divide it by 3 and then I will multiply it by 3, and as these are integers, I will just it will just omit the fractional part and I will get the value. Now let me quickly show you how I do that. So I will say grid X equals to call, because X belongs to the column, and I will divide it by 3 to get to the particular column, and to get the cell number I will just multiply it by 3. So my result, technically, even though my column number is 1 2 3 4 5 6 7 8 9, the result can only be 0 3 or 6. Okay, so the same thing goes for grid Y. So I will just say int grid Y equals to row divided by 3, and then I will multiply it by 3. Okay, so I get this here. So now I have this cell number, and now I have this cell number, and I have to loop through all these cells. So given this cell in this box, I just have to look into these 9 cells to find if any number repeats. The number I am going to place is repeating. So what I will do is, let's say this cell number I will give assigning them to 0 1 2 3 4 5 6 7 8. So if this is the cell, it's going to be 4. Okay, 0 1 2 3 4. So if I divide it with the width, this width, I will get the y axis of this cell. So 4 divided by 3 equals to 1, and that's going to be the y axis. This is 0, this is 1, and the remainder will be the x axis. So this is going to be 1, because 3 plus 1 equals to 4. We can check it for any cells here, like this one. It's the number 5 cell, the 6th cell, it will be 0 1 2 3 4 5 5, and if I divide 5 with 3, we're getting 1, and the remainder is 2. So yeah, in x this is 2, and in y this is 1, because it's starting from 0. Okay, so we're just going to do that. What I will do is I will copy this line and paste it again, and this time I will ask if arrays grid y plus I divided by 3. Okay, y divided by 3, and this is going to be plus, sorry. So y divided by 3, I explained it earlier, and plus I modulus 3 to get the remainder is equals to n. Then we are going to assume this condition once again. So it's as simple as that. Just let me make it a little cleaner. So it's like this, and what I am going to do is I am going to only go through the 9 numbers, and from that 9 numbers I am going to get 0 0 to 2 2. Okay, so 0 0 0 1 0 2, then okay, and after this checking is done, we are just going to return false. And I think that's going to be enough to check whether I can place a number in a cell. So I know whether I can place a number in a cell, so just let's quickly write a function to get all the numbers that I can put in a cell. So it will be a vector because it can contain 9 elements, but it can also contain no elements in case of no number is placeable. So I will just call it a vector of integers. Find placeables, and it will take the array. So int array 9 9, and the row and the column. Okay, and it's going to be fairly simple. What I am going to do is I am going to take a vector, I'll call this can cp, in sort of can placeables or cps. Okay, so I will look through the 9 numbers I can place, nothing fancy here. Okay, and it will be starting from 1, and it can go up to 9, so I is less than or equals to 9. What I want to do here is simply check if I can place the number. So if can place in the array of r row and c column the value of I want to simply push the value of I into CPS. So CPS dot push back I. Okay, like that. Okay, so now let's try to solve the problem using backtracking. So our function, it's going to return a boolean depending on whether it can solve the whole Sudoku or not. Okay, so I'll call it bool solve Sudoku, and it will take the array, the Sudoku array. So it will be a 9 cross 9 array, and it will take the starting row and the column. So starting row and starting column, and I'm going to make this function a recursive function. That means that this function will call itself again and again in order to explore all the possibilities. Okay, so whenever I am done checking all the rows, that is I have checked from 0 to 8th row, I will reach to the 9th row. So whenever my row will be greater than 8, that means I have completed all the cells previously. So I have done the Sudoku, and I can simply return true, denoting that all the previous rows then this particular instance have been filled up. I am done with the Sudoku, I have put all the values successfully, so return true, I have done the job. Okay, otherwise it will be falling into an infinite loop. So Now let's first find out the numbers that we can put into that row or column to begin with, which is the vector of integers. So vector of int placeables, find placeables, and I will pass the array, the row and the column. Okay, and this will give me all the placeable items. We will check if we actually have any placeable to begin with. So if placeables dot size is equals to 0, that means we cannot place anything else on that cell, so we'll just simply return false. So assuming that we have some placeables, now we can, what we do, we can take a status just like previous time. This time we will set it to false, stating that we can't continue any further, and if a particular instance of our trial is successful, then we will get that instance, the value from that instance, and we will return that data, stating that this is a perfect solution. Otherwise we will be returning this false status, so I will just return this status. Now let's get to the interesting part, the finding of all. Now let's get to the interesting part, the backtracking of all the possibilities. And it's fairly simple enough. What we will do is we will loop through. So for int I equals to 0, sorry, int I equals to 0, I is less than all the placeables, so placeables dot size I plus plus. So we will loop through all those placeables and check for each possibility. So first of all, our number int n equals to placeables I. Okay, now we need to copy this array and run this whole algorithm on that copy, and if that copy successfully computes, then we will replace this array with that particular instanced copy. So first of all, let me create another function called copy array. It will be very simple, so I will call it void copy array, and all it will do is it will take an array and it will make a copy of it. So I will call that array copy or array cpy, which is of the same size. And here, so we'll simply run two for loops. For int y equals to 0, y is less than 9, y plus plus, and then for int x equals to 0, x is less than 9, x plus plus. And simple enough, we will just store the value of array into array copy. So array copy y comma x is equals to array y x, and that is all copy array is all about. So yeah, we're done. And by the way, whenever we pass values to a function as arrays, they are considered as pointers, because at the end of the day, pointers and array both are just memory locations, so they are the same thing. And so this actual variable that will be passed here will be modified. That's a great advantage of arrays over a normal variable. So let's copy the array. So we will create an array first. Okay, so int array copy, which is of size 9 and 9, and then we will copy this array. So copy array, it will take our original array and it will copy it to our array copy. There are a lot of copies here. So array copy, okay, and here we'll pass the row and the column. equals to n. So this is the possibility that I am going to explore. Okay, I am going to check if this copy is solved. So I will call solve Sudoku on this new array. So array copy, and I will provide the next row and column that is empty to evaluate. So let's say we have something like int next column and next row, and we will put them here. So next column, let's put t here. Okay, this is not next but next column, and first of all it goes row, so next row here, next row, like this, like this. Okay, so if this solve is successful, and if it successfully fills all the rows and columns, I can just simply think that array copy is the perfect answer. So I will now copy back array copy to array. So I will say copy array, and this time I will copy array copy to our original array, and also I will set the status to true, and also I will not explore any further because I have reached my result. So I will break from this loop. Okay, it's a good practice to break out of the loop whenever you have successfully done your job, so that the extra loops, they can be avoided. And yeah, it's basically done. Now the only thing that remains is finding the next column and the next row. So we can I can write it right here, but I would prefer to have another function that will find the next column and the next row. So I will call it here void next empty, pmpty next empty, and it will take my array 9,9, and it will take the row that I am already done calculating. So int row and int col, and it will give me the next row and the next column. So int next row and int next col. Now these next column and next row, for short I'm going to just call these n row and n cols, stating that these are next row and next column. Now these next row and next column, I'm going to modify the original values of these variables. So I will take them as references, so the original variable gets modified, not the variable copied for this function. First of all, I will declare a high index. So let's consider the high index is 9 times 9, cause it will return 81, and our cell starts from 0 to 80, because there are 81 cells and they are not starting from 1 but starting from 0. So number 81 cell means I have already done with all the cells. And now what I am going to do is I am going to loop through all the cells starting from this location, this row and column, and whenever I find the value of that cell is 0, I will return the row and the column number of that cell. So what I can do is I can run a loop for int I, and this time our I starts with our current cell, which is obviously our row, times 9, because whenever we cross each row we are crossing 9 cells, plus our column, that is our current cell, plus 1. So the next cell, we are starting from the next cell. We are exploring until we have traversed to all the possible combinations, which is 9 times 9. Okay, and we are simply incrementing I. Okay, and here we are just going to check if it says 0. So if array, we have already seen how we can deduce the row and the column number for my index, but this is a 9 cross 9, so the only thing is going to be changed is 9 instead of 3. So I divided by 9 for the row number, and I modulus 9 for the column number, and I'm going to check if it's a 0. Then I'm just going to set my index equals to I, and I will break. Okay, so the row number, as you can already know, I n row is equals to index divided by 9, and the n call is equals to index modulus 9, and these values. Okay, the row number and the column number. Okay, and as these are set, so I can use this. Okay, so I'm going to fill this next row and next column, saying next empty my copied array, so array copy, and my row and the column, and find out the next row and the next column. Okay, something like that. And so I have my next row and next column here, and I can do these steps. So it's almost done, except the fact that we haven't considered a single possibility. I will just simply check if array row call is not equals to 0. If that cell is not equals to 0, then just do this thing once again. Okay, do this whole thing once again. So I will just copy this, and I will paste it here. So what I am going to do is I am going to once again find the next row and the next column of my array, and I am going to resume from there. So I will just say return solve Sudoku array next row and next column. Okay, so with this we have done writing this recursive function. So once again, if I am done computing all the rows, I will return true. Whenever I find that a cell is present, I will skip that having a value, I will skip that cell and start computing to the next cell. And by computing, I mean that I will find all the placeable values. I will check if it's there exists a value, or I will just simply return false, saying that this is a wrong possibility, there exists no placeable here. And otherwise I will just create a new copy of that array, and I will check whether whether putting a particular placeable value into that array cell, it's solvable or not. And if it's solvable, then it's going to call again solve Sudoku for the next cell, and that function is going to call solve Sudoku for the next cell, and so on until all the cells are explored. And whenever a cell positively returns true, I will copy the array copy which is now containing the solved answer, and I will copy that to array. Okay, that's it. And then I will set status to true, and I will return that status saying that yeah, I have successfully or unsuccessfully done solving your problem. Now what remains is printing the board after I have solved the Sudoku. So let's call the function solve Sudoku on our board, giving the starting row and column as 0 0. Okay, and then we will again print our board to confirm that if our Sudoku is actually solved or not. So now if we run this program, you can see that there is some error, this is not working. So just let me quickly check it out. So what I will typically do is whenever I am solving the Sudoku, I will clear the screen, which I say that you don't do it like this, but again I'm just doing this for quick visibility. So I will say system, and I will clear the screen CLS, and then I will print the Sudoku once again, and I will pass the Sudoku. So array. Okay, just to see what's happening. So it's putting all the values, but for some reason it's not calculating the placeable correctly. So I will just go here and check what's wrong with can place, because I think that there is an error in can place. So it takes the row column and n, it takes this, is returning false instead of status and returning it inside the for loop. So what I will do is I will delete this line and I will return false. It returns the status here, space status. Okay, so now if I run this code, we can see that all the possibilities, they are being explored here. You can show that as a visualization, but there will be a lot of possibility explorations. So I will just remove these lines and I will show that this algorithm runs actually very fast, because our computer can compute around 6 billion instructions in a second. So it just runs instantly and it returns you the same result as this one. So you can compare here, it is 4, then 6, then 8, and so on. So that's it for today, guys. Hope you have enjoyed this video. Please hit the like and if possible subscribe. It helps me a lot. It encourages me to make this kind of videos. Thank you very much. Bye.